Hello again. Now it's time for you to show me what you know. And hopefully you did this practice quiz and you're checking your work. To be safe, because this is really a time of we just don't quite know, but to be safe and to protect yourself, do your quizzes, show your work, and then just submit them either with a picture from your cell phone or if you just need to type out the answers in a Word doc and submit that to me. If you can't take a picture on your phone, that is okay also. But it's just a way of having evidence that you did this, since it's so hard to really keep track of what you've been doing when we're not meeting face to face. And I'll just put little check marks down. I've got your class list printed. And so all I'm going to do is just put a little check mark down, probably 5 quizzes by the time we end, that you did this. And so that's the best way. Take a separate sheet of paper. You don't necessarily have to print these out and do your work on them. There's going to be 7 or 8 problems. Everything that I can fit on one sheet, I'm going to stick close to Mr. May's length so that we're consistent with our assessments. They won't be the exact same problems, but they're going to be very, very, very identical. All right, so solutions to your practice quiz. So tier 1 is getting at the inverse idea with solving an exponential and solving a logarithm. So the inverse idea is you're going to do log base, whatever this base is, log base 4 of 4. And then that exponent comes down in front. And then log base 4 of 4 is 1. Same thing here. This is how to solve a logarithm with an exponential. So 5 to the power of log base 5, that's going to produce a canceling effect. Then whatever's in those parentheses is going to come down in front. And so I want to emphasize whatever is in those parentheses is going to be the next line solution. And same thing here, whatever in the exponent position is going to come down in front. Okay, so solve these. Very close to the homework problems, and there's a couple of simpler ones and a couple that you got to use a little bit of thought process to get it set up to be ready to solve. So you remember me talking about getting exponentials set up so that they're ready to solve. That's what we have to do in these 2 problems. Okay, and then over here, we've got to get the logarithm in the situation so that it's ready to solve. That's just my next page here. Okay, so we got to get the logarithm set up here or here to be ready to go. So with the 2 exponential problems, you're going to have to, on number 3, divide by 5 first. And now from here, you might be able to even mentally do this one. But let's assume you can't mentally do this one. You would do a log base 3 on both sides to, again, bring down that x minus 1 out of the exponent position. So log base 3 of 9 is 2. Again, if you don't have a calculator that does log base, just do the change of base. You can do it on an internet search bar. And log of 9 divided by log of 3. So how does the change of base formula work again? Oops, gosh. Log of 9, close that up, divided by log of 3. So how does the change of base formula work again? It's log of whatever is the index, whatever is in your parentheses, divided by log of the base every time. It doesn't matter what particular log you have. Let's say you had log base 3 of x and you were graphing, it would be log of x divided by log of 3. So you apply the change of base formula and add 1 to both sides, and that is 3. Let's do number 5, and then I'll do 4 and 6 because those are both logarithms. So in number 5, you need to get everything in a base of 2 because we need the same base on both sides like this to apply this work. So we need a base of 2. 16 needs to be written with a base of 2, and that is 2 to the 4th power. Okay, so that's might be a little bit of a guess and check. You just need to figure out what that particular base is. And then you want to use the rule of exponents that says a power to a power. When you have a power to a power, you take the product of the two. So if I said like 5 squared to the 3rd power, that would be 5 to the 6th. Yeah, so that's what's going on when I rewrite that. And now you're ready to do log base 2 on both sides. And just to save a line, the log base 2's will cancel out. And now you're ready to solve. So subtract x on both sides and then divide by 3. And you have it. Okay, our logarithm problems. Now we need to get a single log statement on one side or on both sides. So that will involve a couple of things. Subtracting 6 is the first thing to do. And then divide by 3 is the second thing to do. And now we're ready to apply an exponential to both sides. So these are both going to go into the exponent position. With a base of 3. Okay, so this base here is what decides the base. And the result of this is 2x plus 5 equals 27. And the 3 to the log base 3 drops, and then it's 2x plus 5. Subtract 5, and you have 22. And then x is 11 when you divide. Here, what has to happen is you have to employ the rule of simplifying logarithms. Okay, and this is in your number 2 note packet in the 3rd page here, laws of logarithms. You need to apply this to get it into a single base statement. And as long as you have the same base, you take the product of the indices of what is in the parentheses. Okay, so log base 3 of 4 times x minus 1, 4x minus 4 equals log base 3 of 2x. So now you're ready. Both of those are going to go to the exponent position, and the base is going to be 3. I'm not going to write that, but you got the idea. And now we're ready to solve. So 4x minus 4 equals 2x. And however you want to do this, subtract the 2x and add 4, and then we get 1/2. Sorry about that. Make that x equals 2. Again, I don't have you guys in class to correct me. If it was 1/2, we would have a problem. That's why I paused for a moment. And it's good maybe that this came up. You can't take the log of a negative number. So if we did get 1/2, if that was the right solution, you'd be a log base 3 of negative 1/2. That's impossible. So watch your solutions with logarithms. So we're good up here on this one. 22 plus 5 is 27. So you just want to make sure that inside those parentheses, you always have a positive value. You can get negative answers. It's just that when you go to substitute it in, what's in those parentheses has to be positive, or you can't do log of a negative number. All right, 7 is what we did yesterday. And pretty much you want to use this formula here, the Pert formula. And so you want to substitute everything in that you see there to solve for R. And yes, the steps are exactly as we learned yesterday. So 40 is left, 56 is initial, E is the natural exponent to the R times 8 years. So you're going to divide 40 over 56, and whatever that gives you this not very nice number. So I'll just put it as 40 over 56 equals E to the 8R, and then you need to do log base E on both sides, which we know, again, is ln. The 8R will come down. So that's the whole idea of logarithms, is to get that exponent down. So R is going to be ln of 40 over 56 divided by 8. And whatever that gives you. Okay, so there's 40 over 56. Then I'm just going to do ln of that. You can go and grab it like that, or use your answer function, or type in 40 divided by 56 over 8. So negative 0.04 rounded to the nearest hundredths place. I think I mistakenly said tenths place in another video, but it's the nearest hundredths place that we want to round that to. All right, and so now we need to build the main function. Your initial quantity P and R are constants. They remain the same throughout the whole problem. And so whatever questions are asked from here, those values never change. It's your T value that changes and your A of T that changes. Okay, so find the half-life. So that's when half is left. And yes, you should be, if you've been following along, you should know that you're just going to end up with ln of 0.5 over R every time. Okay, because when you divide, half is left, so you always get 0.5 to the left. And then you take ln of both sides, and you have negative 0.04 t equals ln of 0.5. Then divide by R to get t. So I will actually do all of that out. So what I'm saying is use that formula. If you understand that, every time it's going to work out to be that. So ln of both sides. That's 1. And now you want to just divide by negative 0.04 on each side to get t. So that's what t is. So ln of 0.5 over. And that gives you about 17.3 years when you do that out. Divided by negative 0.04. 17.3. Okay, and that essentially is what you need to show me on the real quiz. And yes, I encourage you to check out your answers like I did here when I had to pause the video. It's just good to know how to do that. So I'll show you one check here real quick. Number 5, if you say the answer is negative 1/3, then that, Okay, kind of a weird value. Has to be the same as that. You should go through and do that. Just make sure, even though your quizzes aren't getting graded, that you have the right solutions. Again, when you get your quiz done, just take a picture of it, or if you need to just kind of roughly type things out in a Word doc and send it to me, that's fine. You can just take a separate sheet of paper. You don't need to print these off the site, and do your work on that. That will be good. And then email it to me. And again, I'll just keep a little tally of the quizzes that you have done, just as proof that you did it, to be safe. And so Monday, and I'll go very slow. So the practice quiz will be for today, and then Monday will be your quiz day. Tuesday, you'll have, maybe even before that, access to some new material. What I'm going to do is I'm going to pull up, so it's functions, composite functions, inverse functions. I'm going to pull this up. I don't have any material in there yet, but I'm going to pull it. It's always going to be at the top here, what we're doing. So this is going to get shoved down on Tuesday because we're going to be done with it. And this is going to get pulled to the top, the functions. And I encourage you, look at the Khan Academy stuff. It's a little limited in its teaching, but it's good practice. So the best of both worlds is always the best thing. And again, look on Tuesday for your next unit to begin. And have a great weekend.